So let me share my screen, friends. So yesterday we were talking about functions. In that we had discussed about different functions, even including higher ordered functions, and we had discussed about map, reduce, filter, and zip and unzip, all different things in yesterday's session. So today what we do is we try to. There is one more important topic because you can expect this even for interviews as well, and this is called decorator. So what is decorator actually? This is something really one of the very important topic in Python. But not every time everybody will use these decorators. But there are situations where you might need built-in decorators. And very rarely we try to create customized decorators. But this is a question maybe you can expect more in interviews and then also in this one, certification exams. So having a clear idea about decorator is would be very helpful for aspirants. So now if you just see decorator, what is a decorator here? Simple. As name says, a decorator is a function, same like any other function. Now you have some idea about inner functions, right? So it is something like inner functions. The difference is here decorator will is something which modify the logic of a function without actually modifying the existing function. So that is decorator. If we just see this definition without actually modifying the original function, suppose you have two functions here, f1 and decorator, and I am saying good morning, okay, hello, name some good morning. Now I want to add something to this function f1, but I don't directly do any change on this function. So without actually touching this function f1, I want to make some change to that. And in such cases, we apply this decorator. So decorator is a function. What it does is it will modify the original function without actually modifying that. So that is what decorator is. And that change happens in the decorator, not in the actual function. And whatever change we have happens in the decorator is applied to the actual function. And this kind of scenario is called as decorator. So now if you just see this, you don't actually change the function, but some change is applied to that. And for that, we use decorator. So what is decorator means? Decorator is a function which makes change to the actual function without directly modifying the original function or the actual function. And that's what decorator is all about. Okay. And let us see the example. It is not that really, difficult to understand. This is very simple thing. And then here one important thing is decorator takes a function as a parameter. And here what do we have inside decorator? Decorator has extended functionality of the original function. Means in fact what decorator is more or less, it is an extended function to the existing original function here. And what is the advantage of decorator is we can extend the functionality of a function without actually modifying that function. And that is the advantage of decorators. And this is the simple example which helps us to understand what exactly is a decorator. So now the point is, this is a simple function you can see here. If you look at this, we don't have really that difficult code here, just an F1 which takes a parameter name and we are just printing hello, that name and good morning. Now we are adding something on top of that. What is that? If name is some Mano, right? Then I am saying hello Mano, today it's training. You got it, right? So that is the point. If I pass Mano, I get uh, along with Mano, I get something more extended functionality. What is it? It is raining as well. Apart from what we have here, that's it. And simply it's a kind of inner function here. So this is the original function. And to this we are just modifying. If the name is other than Mano, so if anything else is there, it won't have any impact. But if it is Mano, we should add something like this again, like this. Maybe you can add whatever you think is best fit for your requirement. Okay. So what we are doing here, So to add this extended functionality, apart from what we are saying, good morning, and if you want to add something that it is raining, which is adding a extended output to the existing one. That's all. Now, what is that you create? You create a decorator which takes function as argument. So that function is nothing but your parent function. And now what you are doing, we are creating an inner function, and that inner function accepts some name here, okay, as a parameter. And this name is actually passed from the this function which is taken as parameter. Now what we are doing, you are doing a simple validation. We are not really doing something uh, extra here. This is a very simple change. What is that? If name is Mano, then what you are doing, you need to add this functionality. That's all. And then else, if it is not Mano, you have to return that function as is. That's all. Okay. Only when we have to make some change to that function is when name is when this guy, then you should add something more to that. That is extended functionality. Else you have to return that uh, we have to call that function as is. That's all. So this is actually a function call, and you are making this. This is like a kind of a reverse approach. Generally, we call inner function from outer. In this scenario, we are calling outer function from inner. This func of name is nothing but this is a call to this parent function or original function, right? When you say function of name, which is called, this function is called, and the same function is called here. Which function? This one. And that hello name good morning is just printed. Suppose when name is Mano, then that changes. And finally, once you make this change, you have to return that inner. So we will just try to see what would be the result here when we just test this. One important thing is this is the decorator. What decorator is doing is on top of your original function, we are making a small change here. What is that change? If name is Mano, then you should add some we should change that the print we do here. This is extending. Else we have to call that function as is, that's all. And finally, you have to return that inner function. And all this inner concept we had already discussed in yesterday's session. And this is fine. And one important thing here is if you see here, mostly decorator is implemented with having inner function. Second thing is this is our original function or parent function. And on top of that, if you want to apply decorator to this function F1, what is that you should do is you should apply a decorator by using at the rate symbol here. You can see here at the rate decor. So what happens when you call F1? So that will on top of that, it will call decorator automatically. And we are not explicitly calling decorator here. So this, whatever the annotation we have here, this will help us automatically invoke this decorator function. And whatever the extended logic that is applied here in this inner function, that is applied to your original function F1. So how this works, we'll just quickly check and see. Okay, so we do one thing. You take this example. So let us see here. You can add a new file here. So you can say decorator demo. Okay, enter this and then come here, put this here. Okay, now, so this is the simple idea. Anyhow, we will just do a quick tracing as well to just see. So what is that the change we are applying to this function is just we are adding this extended functionality. This one, just this is the extended functionality. We are passing the function itself as a parameter here, and from that we are trying to get that name parameter. And finally, what is that? So this name we try to get it passed from the function itself. And then we are just doing a validation and changing the print the way we print it. Okay, let us do testing here. That then you get some idea. And we try to apply this decorator, whatever we created here, by using this at the rate on top of this actual function. So now let's create two test cases. Okay, test case one. I say that F1 of so my name is here. I just try to pass John. Okay. So now let's run this. John means is the validation we are doing is John? No. Then right click run this. Now you can see you just say hello John, good morning. That's all. This just actually what happens? Decorator is called even in this case, but here this validation is not passing, so it will just call the parent function as is, and that is written back finally. Got it right? Next, you do one thing. One more thing is again F1 now. Suppose you just say, and then now you pass mono. Now right click and run this. Let's see what happens. Okay. So now you can see here. You do one thing, just comment this so that you get an idea. If you have both, you might get confused. So I'm commenting this. Run this now. Now you can see this time you are not getting hello Mano, good morning, but you are getting hello Mano, today is raining. So to this existing function, we are making some change without actually modifying this function. What is that change? You can see we are getting a totally different output, and that is coming from where? That is coming from the decorator here, that too from this validation. Okay. So this is how what we can do is without actually modifying the parent function, our original function, we can make some change on top of that by applying a decorator like this. And decorator is nothing but a simple inner function we create here. And in that, what we do, we try to do some validation, whatever you think that is needed. And finally, what is that? You have to return that inner function, the whole inner as is. That's all. So now if you want to check the execution flow, you can do one thing. Put a debugger, right click and say debug the decorator demo. So now what happens? Let's see. It's still in the this one. Now what do you do? Just apply step into. So here you don't say step over, but say step into. So when you say step into C, I called F1, but you can see where the control is. It is in decorator. How why this is happening? Because we have a decorator on top of this F1. So when you call F1, automatically the decorator on F1 is automatically called. And at the same time, so this F1 is passed as a parameter to this function decorator. Okay. So now to the this F1 is passed as a parameter to decorator function. Now you can see F1 has what? If you have any doubt, you can do one thing. You can print the object of F1 and the function parameter you passed here. And you can check here, otherwise put a cursor here so that you get that idea. See that object there. And also suppose you see here, even you put a cursor here, see the object here. Both must be same probably. So let's do one thing. Put cursor here. So 3790. And here also it should be, see some difference here. This is okay, we'll do one thing. Just print F1. And here also print just for testing purpose. Generally that parameters will be same. Okay. Func. Now you get this. Okay, this is different. Again, this gives you a different, totally different object again, inner one. We are talking about outer. So the parameter we are passing here is this one, built-in function. We can see in the output now. So now we are at this point. So now what is that? What's happening here? So this inner function is called, because when you say return inner, before returning inner function, all this is added to that. This execution happens in the inner. So it goes to inner. It does this validation. Now you can see that. So is this name we are passing is mono? Yes, it is mono. Then this code snippet gets executed. Now you can see here. So the execution is completed there actually. So it validated that and it came back. So now again, step over. Now you can see we got this extended. This is true. So this statement is executed. And finally, whatever that is there, this code that is applied on top of this F1. Finally, we got this hello. It's raining today. something. Okay. Now, you do one thing now. Right click and just run it. Remove the debugger. Yeah, let's run this. Now you can see this. Okay, this is returning a decorator together. At F1, we have this is the object of F1, but while returning, it is including this one as well. Okay. Generally, what is that is this parameter is nothing but I just want to show that this is nothing but because as decorator is applied, so that it's making a change to that object thing there. So, but this is this when you apply decorator, this parameter is passed as a function to this one. This whole function object is passed parameter to that. Then we try to call that name from that. That's what happens implicitly. But as we are applying decorator on top of this, there is some change that is happening because of that thing. It's okay, fine, no problem. Just yeah, this should be. But overall, this is the idea of decorator, friends. So what is decorator and why do we need it and how we create it? So it's a simple inner function. Just we add some change to the existing function without actually modifying it. And to link this to, we apply this annotation here at the rate decorator. And in real code, anywhere if you see this at the rate symbol, mostly they are decorators, nothing more than that. So this is idea about the concept of decorators. Okay, so usually this F1 and this generally would be same if it is a normal. Let me just show you one example with a small example general because we are adding decorator implicitly that object seems to be getting modified, but it's okay, fine, no problem. Suppose you say def F1 and then not F1, def, yeah, F2, and you can say something like name and something like func. Okay, if you are passing function as parameter, then you can print that func. Okay, then what you can do now, you say F2 and this takes function as parameter, right? You do one thing, you take one simple lambda, lam, pda, lambda, some x colon, print something like, you don't even need this print, you can directly print, I believe, because this is print hello. Otherwise, you can add a name here simply. Just want to show you that a name. So this is object, right? So what you can do is on top of this, now what you can do is we have to pass name. One thing, let's do one thing. Now you can see this is the lambda function, right? You can see here. So that we are passing again to F2 as a parameter. And this is just creating a function object here. Okay, fine. So this should be called just a minute. For this one important thing is we can also do one thing. Yes. What is that? So here actually this is printing the address of lambda. You can do one thing. Let's apply ID of this F2. Run this and ID of this function as well. Just to show you the address that both would be the same. Mm. Okay, this is fine. Okay, I'll just and also we can do one thing there. At the same time, I am passing this as parameter as well. Okay, so this is passing as parameters. In the first case, we are trying to check ID. Okay, we'll just test this quickly now. So let's run this once. We're closing all fine, right? Yeah, should be perfect. Lambda, yeah, run this. So should we add anything? Just remove this here in the beginning. This is not needed. Okay, this should be fine now. Let's run this. See, so this is the ID here, the call. There is a change, yeah. This is the idea. Okay, because we are calling in a different thing. In the second case, again, it's creating a different address. Okay. So what I need is I want to just check on. But I will do one thing. Just let's just quickly check here. Check ID in caller and in function. Yeah, you can see this. Yeah, ID in color it should be same, and ID even here inside function should be same. Let's try to copy this code. Just want to show you that because the function what parameter we are passing as function will have same IDs. I want to show you that, friends. So that is my idea. So yeah, you can see this guy. This makes more sense actually. Now if you see here, okay. So one small thing is here just he is assigning to some external variable and passing that through function call. So that that check will make us easy for us. Okay, anything. So only thing is here to get better this thing, you can do one thing. My LIMPDA equal to, let's do this check. Just want to show you that the parameter we are passing is nothing but the same, this one, whatever the. Now on top of this, if you want, you can try one thing. You can just print ID of my lambda. And now just do one thing. F2 of just pass this function, my lambda. And if you want, you can print it. That the idea is not about just printing. It's about, so here, if maybe you can say func of, you can do a function call directly here. And this lambda is called here. And then that whatever here. To this, we have to pass a parameter because it is expecting name, right? So one value you should pass something like Peter. Okay, I pass Peter. Let it be there. The idea is checking ID here. Let's run this and see. Now you should see this time. See perfect. And this is here. This ID is coming from here, and this ID is coming from second ID is coming from here. And you can see even lambda is called. It's more or less calling a decorator. See. So what is that? Here we are applying a function call, and from the outer from the this outer function, then this lambda is called from there, and then this whole definition is executed, and then that hello Peter is printed. This printing of function happens where not in the outer function, but inside the this F2. And here one important thing is the IDs of both this one and this one are same. You can check now. And thus I just want to show you that whatever we are passing here, this one is nothing but this one. Because we are applying decorator, the internal this thing is getting modified, that's all. But here this example gives you a clear idea. Got it right, friends? So overall, this is idea about what? This is idea about decorators. You can explore little bit. You can explore more, but these are something really. This is something really useful for interviews, friends. Okay, so and then also for this thing. But if you ask me, my experience with decorators in our development, we generally don't apply much decorators. Whatever the development or automations we do, we don't need decorators. We didn't apply. But where it might be needed, this is exclusively needed when you are working on web development. You know, right? So this web applications are web development. In such cases, definitely we need decorators. Okay, we build these kind of things. Okay, next after that is so we are done with this one, friends. Which one? We are done with the concept of functions and then decorators. Definitely, we have a very good coverage on functions. This is definitely useful for us. So next after that is what is that, friends? So we had discussed all this. This is done here, friends. So we don't have anything there. So next topic is file handling. We'll get into this today, and then we'll try to cover as much as possible on file handling. And then after this, we jump to module topic. Okay. So what is file handling? This is something really useful, needed, and important in development. But as a data engineer, for you, very rare that we apply regular file handling. Okay. Generally, you prefer more on pandas or something like that. Okay. So, but first starting from here is important. We are not directly jumping into pandas. Pandas will be the our last topic, or at least it will be in the uh, last couple of last listed topics. Okay. When we go there, definitely we have a detailed coverage. But for now, this file handling is regular files or normal file handling. So first have understanding even this is something really important because in certain cases, even this is needed for us. So what is this file handling here? This is the question. File handling means simple, friends. So if you want to, generally, you know, right, we store data in multiple ways. We preserve data. So what is that? One way is using databases. That is at large scale or huge volumes of data. A second way of storing data is writing something to a file and keeping it somewhere. Generally, files are used to store some small volumes of data, not large volumes or huge volumes of data. And if you want to store that small volumes of data at some location in the hard disk, then we prefer file handling. And these are different modes we work with file handling. You can see here read, R for read, W for write, A for append, and explore X for exclusive creation. If you want to create just a file exclusively, then you can apply X. And to deal with binary files, we use RB, same like the first one, RB, WB, AB, read binary, write binary, append binary. And XB is similar to X, which is used to exclusively create binary. R plus W plus and A plus, you can do both operations at a time. R plus is more or less doing read and write, W plus write and read, A plus append and read. And similarly, same thing we can apply on binaries. Okay. So what is that? So read binary and write binary. W plus means write and read all this. You can just quickly check there. This is not difficult to understand. So when you are working with files mode, these are all what we call this is file modes, friends. So what is that? We call this as file modes. And file modes are essential when we are creating a file. If you want to do some operation, you create files, right? So while creating file itself, we specify the file modes. So that is how this is important for us. Okay. So now what is the point here? What file operations we do here? So generally, these are the file operations anywhere in any language we do. What is that? Opening a file. That is, we just apply open function. And file operations in Python is very simple. Trust me. If you go to C++, C, Java, in all these languages, slightly it will be little complicated. But in Python, file handling is very simple and very straightforward. And it is quite interesting as well. So what is that here? What file operations we do? You just had some idea about modes because modes are very important ones. Okay. So next after that is what are opening a file. This is what we always do. For that, just apply open function. Reading or writing a file. Just you can see it. These methods just they are very straightforward, friends. If you just look at that name of methods, you understand what we are doing here. So reading or writing. To read a file, we apply read. To write a file, we apply write. Of course, this read and writes, we might have more read functions and more write functions. We see here at the discussion thing. Okay, while discussing, we will also discuss all that, all different types of reads and all different types of writes what we have. So this is another important. Once we open file, we read file or we write file, and then we display the contents of and our generate reports, and finally we close files. And these are the file operations we apply. And while opening file, we use any of these modes, probably read mode, write mode, append mode, or X plus, R plus, W plus, A plus, whichever you think is best fit for your file operation. Okay, friends, these are the requirements. What is that? Create a file, write data into a file, close the file. This is requirement one we are going to do right now. And requirement is two is create a file, not create, open a file, we should say here. For first time we create files and then write some data and close it. Once we create file, just we need to open that file, read the data and close the file. Okay. So maybe what I can do is I can simply say, while reading, you don't need to create files. But while writing for first time, if file don't exist, then we have to create a file. Otherwise, we don't need to do that. Okay. So this is all about and in requirement, you can do both read and write and do if you want to do in both one program, you can also do try that. We'll just see that. These are very simple things. We don't need to worry much about it. And just filtered file modes. Already we have just had the list of this. And simply speaking, these are most used file modes, either read, write, append, R for reading a file, W for writing a file, and A for appending a file. And default file mode, if somebody asks you what is default file mode in Python, then R is the default, reading is the default file mode. So when you are doing reading, even if you don't mention R, you don't have any issue. Okay, got it right, friends. So this is the idea. So even you can also, if you want, you can also apply this extended modes here, where R plus, W plus, or A plus. Anything is fine. Now you know file operations and then you know file modes. Then what is that you should do? You should apply some programming. So now this is what you have to do. These are the steps we need to follow while working on files. What is that? Step one. So you have to open a file. You have to pass file path. So full path is always best thing. So that full path generally we call it as absolute path. Okay. Sometimes we pass relative paths. Relative means just that name of file. It just sits in the same location as that where we create that file. If you specify full path, you can change the location of that file where it should be created or from where you want to open. But always the best thing is always providing full path is the always the recommended and standard approach. And then we have to pass mode. So this is how you can open a file, friends. Just provide that file name with full path and then the mode that creates a file. And here you can see here one note we just have created. Create and opening a file if file doesn't exist. So when we should when we apply this open function, what this does here? This creates a file, whatever you are specifying here, right? And open a file if the file doesn't exist. If already file is there, then this open function doesn't create file. It just simply opens that file, existing file. You got right. So that's what open does here. You can do condition. I mean, you can apply a check as well. If you are opening a file, before that you can see if that file exists or not. Even that you can do. This is some sanity checks usually developers do in the code. If you want, you can apply that. Okay, but this is step one. And what is open? How to open a file or create a file. So what this open does, whatever file name you pass, if it is not there, then it creates and do some writing. Generally, this creation needed when you are doing write operation, not read operation. Okay. So this is idea about step one. So we have to create a file and open that. That is step one. If it is already existing file, if you are doing read operation, just open that and try to read that data. That's all. Next step two. So if already file is there, then read from it. Else try to create file and then write something into that. That's what step two if we do. We just this is just a quick this thing. Later on we will apply everything there and when we see that it's not really that difficult. These are read functions and we have almost four different types of reads in Python on regular file handling. A normal read. So this reads the whole data from a file and returns it as a string. See this. That whole data from a file, whatever the size of the file, how many our lines are there, that all that data is read from that file. It reads all that and returns that as a string. That's what we see all this with examples. We don't need to just think much here. Just only have some idea, that's all. Read of n means just read some first 10 characters, like, first 10 characters, first 20 characters, something like that. Read n characters from a file, even that is written as string. Read lines means same as something read. The difference is it reads one line at a time from this one, but even this returns as a string. Okay, so read line means, as the name says, just reads one line. Read lines means reads all lines from the file and returns it as a list. And this is read and read line are doing whole complete read. The difference is read returns that whole file as a string and read lines returns that whole file in the form of a list. We'll see that with examples so that gives you a detailed idea. And write is something which is used to write a string or some binary data to a file. That's all. And we have these methods to do write operations. We have write and write lines. Two methods are there. So what write does is it try to write a string or binary object into a file. Write lines is used to write a list of strings to a file and you can see here without adding new line characters automatically. It won't add new line. You have to explicitly append that thing there. And also one more way of writing is applying print statement. Right? You can apply a print with the file parameter. Okay, that is one more. And this writes formatted text to a file. And these are three different types of write functions what we have in Python. Okay, let's do some programming. And finally, once you do all this, we have to close files. Okay, so if you don't want to close file, there is another way, another kind of file opening with open. I'll talk about it once we complete all these scenarios. We'll also quickly check on one more kind of open with open. Again, these are might be useful for you for interviews plus certification. That's all. So let's do quick checking on this one by one, these examples. Okay. So what do you do right now? Let's start with this. So you do one thing, just come here. So you can just add a package as file handling, Python package, and then you can say file handling. Okay. and then you can close this here and right click, and then you can see that this package is created. So after file handling, anyhow, we talk about modules and packages, then you get much more deeper idea about that. Okay. So Python file, and then you can just create simple files. So file handling demo or test one, the first program here. So what is this? Let's apply the steps we have observed here. Okay. We'll just apply steps. So probably one more, just a minute. Let me. I just downloaded a PPT as well, just checking for that. It's okay. I'll just keep it ready for tomorrow. So whatever the PPT we have. Okay, let's go continue here. Okay. So for step one, so here creating, these are the operations we are doing. Creating a file and then writing into a file. Okay. And then what else we do? And then we read from a file, not all in one step, we'll go one by one. But this is what we are going to then finally closing the file. Now, first thing, how do you create a file? Simple. So you can just say some file variable or file, this thing equal to open. So you can just provide the name of file. If you want to create that in the current location as your project under this file handling itself, then you can directly just say some file name here, something like abc.txt, and then comma, you open this file in write mode. You can see there, write mode, and no need of any colon or anything, not needed. So, okay. So then this abc.txt, you can check under this package file handling itself. This is called relative path. So the way we created this file is called relative path. When the path of file is relative, then the file is created then and there itself. Now after this, what is that? You have to do some writing. So you created what this does, create an open file for writing. So that is what this does, friends. Next after that, step two, this is step one. And this is what we always do while working with files. Next after that is step two, write into a file. What is that we should do? We have to write into a file here, friends. Okay. So how do you write? Simple. So you can see some file underscore var dot. Yeah, direct. You can see we had discussed, right? We have three different functions to do write operations. Write lines. Writable we don't need, friends. And then print is one more. We can use any of these three. I am directly using write. Sorry. As we are just starting to write. Okay. So this is a test. Okay. So this is how we just write. And if you want, you can add more as well. Maybe if you want to write one more string, you can call write for one more time. And sorry, friends. If you want to do this continuous writes, then you have to create a loop and then just keep on adding data to the file. So that's how you have to do. This is, sorry, friends, just a minute. Yeah, this is test two. And finally, step one, we opened a file and created a file and opening it for reading. Step two, we are writing something to a file. And step three, just we did this two, right? Step three, you can you have to close the file. Simply you can say that file pointer dot, you should say close here. Once we create files, we get a file pointer here. Pointer instance not like in C, C++. This holds that file object. Okay. So through that, we have to, what is that you should do? We should, through that file variable, we have to call methods of file, or we have to close file. And we, if you want to do anything on file, then through this file variable, we just do that. What is that we have inside file variable? Simple, just print it and see. If you want to know, or if we are curious on that, just print it so that you get that idea. And this is a simple program where we are just following these basic steps of creating files. What is that? Create opening file and then writing and then closing, all this stuff. And right click now, run this now. You can see this. When I print this file variable, you can see the file object. There is some name, something. It's you are getting it that file wrapper. So now you can see, of course, fine. When you can see now, file is created here directly under this package file handling. Now, if you open this, what happens? You have that file what we created. Okay, and if I wanted my output to be passed line by line, there is a small change you have to do. Every time you have to just add a new line when you try to enter data, when you try to write data. Just append new line at the end of that string that will try to create output line by line inside a file. Okay, now what do you do? Right click, run this again. And now this time you can see a change in the output here. See, and here this is, we are creating this file in the current location. Now you can ask me a question, Manoram, why don't we create somewhere in E drive or D drive or C drive or something? In such case, what is that you want to do? Suppose you want to create it in E drive. Okay, let me just okay, get that. This is E drive, right? If you want to create directly here, E drive, and I'm creating a simple file here. Sorry, not file, folder. Create a folder. That folder is BI data tech. Okay, let's create it like that. This is my location where I want to place that file. Then copy this path, come to the code. This is full path. Paste it here and then apply double slash here. And here also, what is that? Double slash. So this is something we create file. So this is full path. Now I'm changing my location of file where I want to create. This time, for first time, we are just creating in the current location, right? And but now we are making change to that. Now right click, run this. Now this is created, no doubt. If you want, you can just add a print statement here, print, write successful. And one important thing you should do when you are doing this kind of file operations is always make sure you follow exceptions. Okay, so you can just do all this. Okay, just apply exceptions. So here you put something like except, and just you can choose exception as E colon. If you want, you can print it. So this is one important thing you should always prefer when you work with files. This closing, generally you can move this to which one you have. You can move to the block called finally, but for now it's okay. We can manage with this. Adding finally is not really difficult. I'll talk about even that when we discuss exception handling. Okay, so this is something, this is much more standardized code now. This we see more better hygiene, code hygiene when I added exception handling here. And this file formats, you should not see directly hard coded file formats in development. Actually, this has to come from some config files. So you should create some conf files, and then from there you should read these file paths. But as we are just doing learning, we are trying to apply here itself directly. But in real development, we don't see, or we generally should not see hard coded values in the code. So that is the idea. Okay, let's run this now. We should be fine with all that. Okay. So write successful, then go to the E drive and BAE data tech folder. And you can see this file is created here. Okay. Now open this and see. This is your file, you can see here. And you have data in that. So this is how we can create file and we can write data to a file and we can write close files. And when I print file pointer, you can also see what is there in that file pointer. This is that it's a text IO wrapper object. Okay, and it has all those parameters. What is that file name and mode of that encoding that is applied to that file. Okay, this is fine. Now, what is that? Once we write something to file, I want to read this file. Okay, so next we do one thing. Let's create another program, Python file, read test one. Okay, close this and then just these steps are same. So you do one thing, you can copy this. Okay, till this, that is enough for us. So what is that we are doing here? We are reading a file. Okay, so then now just change this mode or just remove that mode. Even if you don't specify mode, by default it is a read mode. Okay, so if you wish, you remove it. Else, if you think to add some readability, pass that R. That should be fine. Okay, because default mode of file operation is write mode. Sorry, read mode. So if you want, you can pass it. Else, you can even remove that mode. Then by default, that will be treated as a read mode. Fine, you don't need to print file object every time. This is file object. This returns. Now what is that you should do? We have to apply read. How to apply read? Simple. We have how many reads? 4 different types of read functions you can see here. So all this. Maybe we can quickly apply and test it now. So I'll just show you all 4 different reads. After that, I will also show you about all different writes as well. So that gives you a complete picture about file handling. Okay. So, okay, this should be fine. So once we open file in read mode, we know abc.txt has some data. We just open and viewed that data. You can see we open this and we have viewed that data. So we have two rows inside that. If you want, you can add much more as well, just for testing purpose. Test 3 as well. You can do that by program. I'm just adding it. We have 3 different lines. Okay, let it be there. Excuse me, friends. Now after this, I should apply read. I'm applying reading the whole file, just applying read. Okay, what I do, some data equal to some file var dot read. Just apply read. This is just default. It doesn't take any parameter. This just reads the whole file from this abc.txt. So now, and we read that data and just assign that to this variable data. Okay. Now, if you want, you can print it in that data. And finally, what you have to do, you have to close the file. Okay. And then complete this exception handling. So you can simply say exception as e colon and then printing. Sorry, friends. So this is the idea. So what is that we are doing? We are opening file for reading and reading file, applying read. This reads whole file and returns as string, and we are printing it and closing file. So adding exception handling to make sure that this file exceptions are not raised. Okay. So now you can see this. We are able to read that. And this whole thing is a string. It's not like when you see output line by line, don't think that this is something else. This is a string, right? You can see here if you want to see type of data. Okay. And if you want, you can also apply printing. So here, after that, you can apply print as well. Okay. So now you can see that. Run this now. So what is the type here? You can see it is a string. Suppose if I want just to extract only the first line, what shall I do now? Or I want to extract second line or third line. What should I do? In such case, you have to apply split function by new line because you can see there is a new line in each of these. Apply a split by new line and then what happens? Then you can extract whichever line you want. You got it right? Just a minute, friends. Yeah, sorry, friends. So now I want to split this. I want to get first line or second line or third line. It's a very simple operation. Split by new line. That is the best choice we have here. If you have any other way, you can also do that. That's fine. But what is the requirement? If you want, just get that. Just on data, just apply split, and then you can just simply say /n. Okay. That will split by new line and it gives something. So data 2 equal to, and maybe you can print here. Okay, print data 2. That split will split this whole data by new line. Now you can run this. Now you can see there we got a list of files with all that split data, and all that three different lines are. I think some again a somewhere that one more additional space is added. It's okay, but this helps us to do the operation to get what we want here. So this space might be it might be added by mistake when I try to enter some data or something. That should be fine. We can now what is that? I want to get first line. Simply what you can do right now, you can simply say print off data two of something like 0. Something you can just try to do something on files. Okay. Run this. You can see now I am able to extract just first line. So this is a quick idea about doing read operation, getting the whole file as string, and finally what trying to get that first line up after applying split. All this you can do this, and this applying split and trying to get that first line. All that you can also do that in a comprehensive approach. You can also create a comprehension and you can get line by line of data from a this the split doing split extracting line by line everything you can do with a comprehension as well. Okay, so you create a comprehension to do this and simplify this approach as well. Okay, this is about this simple read. So we'll finish all this about all different reads, all different writes, and then we jump to again. So we talk about dealing CSV files, dealing Excel files, dealing all different types of maybe JSON file. Okay, whatever that is needed for us for data engineering and anywhere. This is not just we are not just targeting our data engineering. That definitely this will target that. Apart from that, this is helpful for you to connect to any pathway of Python. Okay, this is overall idea for today. I'm sharing this code base with you. Let me just share this to you. So what I do is let me come here, share the code snippet with you, enter this, share this. Okay, again, what I do is one more file programmer. Okay, I think I shared this, but it's okay. Let me share it back. And then codes, sharing this as well. You can just test it quickly. So tomorrow we complete on all these methods and then also go to that file handling with CSV file handling, all this. Once you get this idea, mixing all these things like your data structure, this file handling, and then all that help just makes you understand pandas very easily. Okay, because mix of all that is more advanced thing in pandas, and that is much more easier. When you see this file handling and see pandas, then you feel that pandas is much more advanced and you can do more with pandas than what we are doing here. So that is the idea, friends. So we'll stop here for today. Any questions? Let me just stop share recording as well.